Hi everyone. Today we're going to talk about erosion. So just to refresh your memory, weathering is when rocks are broken down into pieces. Erosion is when those pieces, which are called sediment, get moved to a different location. So everything that we talk about on this set of notes is going to be all about how we can move sediment from point A to point B, or from one point to another. So here we go. Make sure you're filling in your notes as you see the slides. Okay, first of all, what is erosion? It's the process by which wind, water, ice, or gravity transport soil and sediment from one location to another. So, if I can get my pointer here, right in here at the tree's roots, you can see that the water has actually washed up and washed away the sand, and it has moved that sand to a different location, exposing the roots. So that's what we're talking about when we're talking about erosion. It means that the sediment that was here next to the tree has now gone somewhere different. And the cause of that is that moving water that washes up on the shore. So erosion by water and ice. So we just touched on how water can shift the sand from one place to another, but we can also apply it to this picture here with the ocean. Now, you're going to have two things happening here. You're going to have weathering, where the water pounds onto the rock and it will actually mechanically break the rock. But in addition to that, after it's broken the rock by weathering, that water is also going to wash away that sediment and take it somewhere different. Okay, another way that water can move sand or sediment is at just plain old currents, where the movement of water kind of down the beach can carry the sand with it. In terms of something like your backyard, running water, as it runs along the dirt and soil in your backyard, it can actually create little ditches. And if it rains really, really hard outside, you can go outside and see little ripples in the dirt where the soil has been washed away. Now, talking about ice, we have a picture here of a glacier that's very slowly going to work its way down through the valley, and as it does that, it's going to carry this loose sediment with it. It's going to basically push it downhill. So that's another way that we can have erosion. Okay, erosion by wind. So obviously, if you have wind blowing, or if you blow on something, you're going to move loose objects to a different place. You're going to blow them away. So deflation is a vocabulary word. It's when sediment gets blown to different locations. So this picture is showing you deflation. You can see the sediment blowing around in the air. So abrasion we've already talked about in terms of mechanical weathering, but particles blowing in the wind rub against rock, it wears it down. So that piece is not technically erosion. We're talking about weathering, but then deflation takes place and it takes those pieces and erodes them to a different place. So that brings us to something called the angle of repose. We're about to start talking about mass movements where we have lots of sediment that moves at one time. So if we look at the picture here, this gentleman has a board with a bunch of rocks on it, and he's very slowly lifting the board up. So those rocks are going to stay in one place as he lifts, but eventually he's going to get high enough that the rocks aren't going to be able to stay at the top here, and they're going to roll down the board. That one moment when those rocks can stay up top, and if the next moment happens and they roll, the maximum height that they will stay at the top of the board is called the angle of repose. So if he lifts it any more than the angle of repose, then they're going to roll downhill. So that's important for the next few things that we cover for mass movement. So here we go. All right, types of mass movement. We're going to look at landslides, mud flows, rock falls, lahars, and creep. So these are the 5 ones that you're going to have to know for your test. All right, starting with rock falls. It's basically a rock slide. It's just a fancy name for the rock slide. So we have loose rocks that fall down the slope because whatever has happened, the angle of repose has gotten too tall for it to stay at the top. So those rocks fall downhill, and they can become a problem if, in this case, like they've covered the road. So they can fall on people, or they can block roadways. So people who design roads have to take care to make sure that they don't cut too steep into the roadway because they don't want that angle of repose to become too steep. In certain cases where they know they're going to have loose debris that's up, or loose rocks that's up on the hill, they'll have netting on the side of the road to try to catch whatever rocks fall down so that they don't come across the road like what you see here. Okay, landslides. So that's when we have a bunch of land that moves at one time. The type that we're focusing on the most is called slump. So think about if you're slumping down in your chair, your whole body kind of drops down low in the chair. So this is when a ton of dirt and sediment drops at one time. Okay, so it's basically slumping down on the roadway. So the best defense against this happening is plants and trees. If you think about it, all we see right up here is grass. Grass has roots. Trees have much bigger roots. Roots act like little fingers and they hold the soil together. So if this entire area, instead of being just grass, if they had planted a bunch of trees up here where the roots would extend farther down and it would hold on to that dirt, then the chances of this slump happening would be greatly diminished. It would go down. So even in your yard, the best way to prevent erosion is going to be to have lots of plants, because you have lots of little fingers, in other words roots, that are in the dirt holding everything together and keeping it from getting washed away. So right here, this is a huge clue because there's no trees hardly at all. It's just grass and those roots don't go down very far. So there was nothing holding this together, and so when this got wet and loose, then this whole area had a chance to slide down the hill, and that's what we see as slump, because it's one big piece that is dropped. Okay, we have mud flows. This is basically where you have a lot of rain that gets mixed in with dirt and soil, and everything gets loose when it gets muddy and wet. So it'll start to eventually move downhill, and you can see this is an extreme case where the mud flow has come into an area of houses and it has shifted everything and moved everything around. Again, if you have lots of trees, trees drink water, so their roots are going to hold everything together, but they're also going to pull moisture out of the soil. So the more trees you have, the less chance you're going to have erosion, because it's going to be able to hold everything together with the roots, and it's also going to pull that moisture out of the soil. So trees are a wonderful, wonderful thing to try to combat erosion. Okay, we have lahars, which are pretty much the same thing as mud flows, but they are caused by volcanoes. So if you think about it, lots of volcanoes at the very, very top are snow-capped. Snow is frozen water. So when the volcano erupts, lava is hot, it melts the snow caps, which in turn gives us a bunch of water that mixes in with the ash and with the dirt, and all of that mess comes down the hill. So a lahar is basically a mud flow that's mixed with hot ash, and it can cause all kinds of problems. Okay, last one is creep. So you guys, if you have a creek in your backyard, or even if you have a hill in your backyard, you can probably find evidence that this is happening. So plants want to grow straight up, vertical. If they start to be on the side of a hill, gravity pulls down. So over time, all this sediment is going to slowly work its way downhill, including the trees and the plants, or the fence. So plants want to grow up, straight up. So if you look, you can find evidence that creep is happening because the tree trunks will be curved, just like you see in this picture right here. So they're coming out of the ground, but then since the ground is slanted, the tree wants to grow straight up, and so it's going to turn. So I challenge you to go into your backyard and see if you can find evidence of creep that's happening, especially if you're down by a creek or a little riverbed. You can see this pretty easily. But it is the slow movement of soil and sediment down a hill. So this is going to take probably decades, tens and tens and tens of years, 20 years, 30 years, for you to see something like a tree work its way from up here all the way down. It'll take a really long time for that to happen. That's why it's called creeping. Okay guys, hopefully you have all your notes filled in. If you would please bring them to class, then that would be great. Have a good night.